Hi, and welcome to It's Not Obvious Java Edition, and today I will be talking about basic loops. Specifically, I will be talking about the basic components of a loop, and briefly I will be talking about what programming might be like before loops come around, and then I will go over the while loop, the do while loop, and checking user input revisited, but this time around using loops. I highly recommend before you watch this episode that you watch my previous episode about if statements, and also please remember what Boolean expressions work. That's going to be extremely important for this episode. This episode again is primarily for my CSS 142 students at the University of Washington, specifically at the Bothell Campus, but this is also for anyone who wants to be a little bit more familiar with how loops work, especially in Java. All right, so who am I? If it matters, I am currently a part-time faculty at the University of Washington, and I am also a software manager at Amazon, specifically in AWS Kumo. And if you want to know more about the stuff that I've done and connect with me, please find me on LinkedIn, and I would be more than happy to connect with you there. Okay, before we proceed any further, is this programming? And the answer is yes, this is very much what programming does. Now, the computer is really excellent at repeating something endlessly. Now, at some point, it needs to stop executing before it runs out of space or runs out of memory, but a huge part of programming is the ability for the computer to repeat something over and over again, and this is very much programming. Specifically, if we think about the PET model, if we think about problem solving, engineering tools, and terminology, this is more on the engineering side and a little bit there on tools and terminology. Okay, great. So let's get into it. The basic components of a loop. Some things before you begin creating a loop is you should think about what should happen before the loop itself begins. And you should also think about the starting condition. What triggers the loop to begin in the first place? You should also definitely think about what happens inside of the loop. What is the thing that you want to have repeated over and over again and why? And this is the body of the loop. And at some point, you need to be able to stop the loop, because if you don't stop the loop, then you end up with essentially what's called an endless loop, and that becomes extremely problematic. It ends up causing the computer essentially to run out of space or run out of memory pretty quickly. So you need to make sure that there's something inside of the loop that allows the loop to stop. Now, the other part of that is to ask the question, under what circumstance should the loop continue going, and under what circumstance should it stop? This actually works very much like an if statement, except whereas an if statement says, if something is true, do blah, and then move on. With a loop, it says, if something is true, do blah, and then repeat for as long as it's true. But let's talk about it in terms of the different types of loops that we're working with today. Okay, so we'll talk about the while loop first. In terms of the while loop, the idea is while the Boolean expression is true, keep doing blah. This means that the body of the loop can be any statements, including, for example, if statements or other loops, in other words, nested loops. And the Boolean expression must at some point be false, because otherwise you have endless loops. Now, the other thing to think about here is that while the Boolean expression is true, keep doing blah, this works a lot like if statement. In other words, if the Boolean expression is not true in the first place, the loop never begins. And here the recommendation is that you have the Boolean expression updated in the body of the loop. Okay, let's go to a demonstration. As always, I begin with BlueJ. I create a new project, and let's say loop examples, and we'll do a new class example. And as we normally do, we get rid of all the other stuff because it's not relevant to us just yet. We're getting pretty close to the point where I'm going to go over what these components mean, and instead of getting rid of them. But for now, we go back to public static void main string array args, and let's do the system out print line hello world, so that we have some confidence that this is going to work the way we expect it to. Okay, so we have hello world over there. And now let's talk about the while loop. If, for example, we have while false, then we can do system out print line, this never happens. Compile. Now it's going to complain immediately. It's going to say unreachable statement. The computer recognizes that because this is false to begin with, that means that the statement is never executed. It's unreachable. So it's saying that, hey, you cannot have this. You're putting in a statement that never ever gets executed the way it's written. Don't do that. So, okay, maybe we cannot do while false. Let's do while true. While true. Now we have while true, and we have system.println. This never happens. We compile. First we do hello world, and then we run this, and now it just prints this never happens over and over and over and over again. And in fact, if I tried to scroll up, it wouldn't let me because it just keeps printing over and over again. Now if this happens, if you want to stop execution of the program, you'll see here that this progress bar keeps on spinning left and right, left and right. You have also this button that says Reset Java Virtual Machine. That's the button you want to hit to stop an endless loop execution. Click on this and it says Initializing Virtual Machine, done, and it stops this never. And you can see now that the first thing it did, oh actually, it printed so much that this never happens that that we cannot scroll back up high enough to see the hello world. Okay, so now you have an example of an endless loop. And this is what happens. It just does this thing over and over again, and it never actually stops. So let's fix this a little bit. Let's do boolean is continue expected equals true. And let's do is continue expected. And let's say in here we have is continue expected equals false. So this time, oh, I need the semicolon. So this time, after we compile and we run it, and we get hello world, and this never happens once. So what happens is that is continue expected equals to true. So this is true. And then you execute this statement. The computer executes this statement, printing out this never happens. And the next thing it does is it updates is continue expected to false. That's why this is while true. Execute this line, come back up over here, is continue expected is now false. And so it goes, well, now that this is false, we don't have to repeat, we get out of the loop. Okay, cool. Now, but if you only ever use the loop like this isn't really any different than using an if statement. So we probably want to use a loop so that we can repeat something multiple times. Let's do something a little bit more meaningful. And let's say boolean, instead of boolean is continue expected, we also have an integer count equals 0. And then count equals count plus 1, which means we increment the count by 1 every single time through the loop. Increment count by 1 every time through loop. And then let's say if instead of is continue expected equals to false, we do if count is greater than 3. Then we do is continue expected equals to false. And again, we'll use this neat auto layout feature of BlueJ to format it properly. And now we do compile and run. And we go, hello world, this never happens, this never happens, this never happens, and this never happens 4 times. And then it stops. Why? The reason why this happens is because we are increasing the count every single time. And in fact, we can see what happens here. System out println count. Compile. We go hello world, which is the first print statement. Then we do is continue expected equals to true. Int count equals to 0. and then is continue expected is true, which means that the computer goes, oh, okay, while true, I'm going to run in here, execute the statement, print the count. Right now the count is 0. And then we print this never happens. And then we increment the count by 1, and we check to see if the count is greater than 3 just yet. It's not greater than 3, so this statement is not executed. It repeats up here again, is continue expected is still true, but now the count is increased by 1, so we print 1 and we print this never happens. We repeat again, and this time it print 2, this never happens, print 3, this never happens, and then after we print 3 and this never happens, we increase count by 1, so we do count, which is 3 plus 1, 4. 4 is now greater than 3, is continue expected is false, so this stops the loop because now it goes while false. Oh, okay, it's false now, I can stop the loop. Okay, so let's talk about the next thing, the do while loop. Whereas the while loop allows you to execute the loop similar to an if statement only if the condition is true in the first place, the do while loop guarantees at least one execution of the loop body. Okay, so let's see what that means. Here, if we have boolean is continue expected is false, and we execute this, compile, run, then what happens is we only have hello world. We don't have anything else. Because it prints out hello world, it goes boolean is continue expected equals to false, while false, nothing gets executed at all. It doesn't matter. All right, so let's do and while. Do, and then at the end over here, while is continue expected, and we need a semicolon. This is just the syntax. Okay, so now if we were to do this, even if is continue expected equals to false, we can continue to execute this, and what happens is we end up with 0, and this never happens. Why? Because the way it works is that first it prints hello world, then it goes is continue expected equals to false, is count integer count equals to 0, and then it does the body of the loop first before it checks to see if it needs to repeat. So it goes print count, which is 0, print this never happens, which is what it prints, count equals count plus 1, which is now count is 1. If count, which is 1, is greater than 3, we execute this. 1 is not greater than 3. We never set is continue expected to false, but in the first place, is continue expected is false. So then we get to the while is continue expected. This is false. So it doesn't repeat. Now, if we begin by true, for example, then it behaves very much like the previous statement where we print out 0, this never happens, 1, this never happens, 2, this never happens, 3, this never happens. So now you can see that it works very similar to how the while statement works. The biggest difference is the do while guarantees that you're going to execute the body of the loop at least once, and then it checks to see whether it needs to repeat the whole thing over again. Okay, great. So now you might be wondering, why is this useful and when would we ever want to do this? And the idea is I want you to think about how to apply this in terms of getting user input. So let's do that. We're going to import Java util scanner like we normally do. And then we do scanner s equals new scanner system in. And let's say that we're going to check for some sort of a number again. System out print line, please give us a number greater than 10. Okay, and then we do int num equals s.nextInt, and then we'll first experiment with the while statement. While num is less than 10, and then we'll ask the user again, please give us a number greater than 10. Okay. Now we compile this and we execute this. If we say, please give us a number greater than 10, and we say 19, it stops. Because 19 is not less than 10, 19 less than 10 is false, so it never executes this in the first place. If, on the other hand, we give the number 10, it still thinks that 10 is less than 10. Well, that's not really true, but we will debug what happens there in a moment. And if we were to run this again, and we give it the number 9, it goes, please give us a number greater than 10. 8, please give us a number greater than 10. 7, please give us a number greater than 10. And again, if we come back to 10, why is it that it thinks that num is less than 10? Well, 10 is less than 10. That is not true, clearly. False. So that's what happens. 10 less than 10, false. Because 10 is equals to 10. So because this is false, while 10 less than 10 never gets executed. Okay, so that means that our logic is incorrect, where we say, please give us a number greater than 10. 10 is clearly not greater than 10, it's equals to 10. So what we're going to need to do is we're going to need to do while num less than or equals to 10. Compile this, run this. Please give us a number greater than 10. 11, that works. Please give us a number greater than 10. 7, it asks us for the number again. And now we give 10. And now, because we have the less than or equals to there, we properly get the message, please give us a number greater than 10. And we're expected to give the number greater than 10. Let's say 11. Okay. So that is an extremely common mistake to make for conditional expressions, to use less than or equal to when you're supposed to use less than, or in this case, we use less than instead of less than or equal to properly. You do need to take a step back and you do need to think about how to properly check for the condition in order for this to work. Okay, now what happens if instead of the while loop, we have the do while loop? Do while, and we execute this, compile, run, and let's say if we were to properly give it a number greater than 10, 15, it still asks us for a number greater than 10. And let's say we get 15 again, then it works. Well, the reason for that is because the do while statement guarantees that you execute the body of the statement at least once. So even though you get a number greater than 10 from the very beginning, it continues to ask you the next question, please give us a number greater than 10. Well, maybe we can do something about this. Maybe instead of having the statement out here, we'll get rid of it. And instead of asking the user for a number out here, we'll just say num equals to 0 to begin with. And then we simply execute this directly. Please give us a number greater than 10 and then get the number. And if the number is less than or equals to 10, we repeat the whole thing. All right, so let's see what happens. We compile this, we run this, and let's say, please give us a number greater than 10, and we get 15, and immediately it stops because it does this statement. It gets the number, 15 is not less than or equals to 10, and then it does not repeat because 15 is not less than or equals to 10. Well, let's do the opposite side, and let's check to make sure that if we give it a number less than 10, less than or equals to 10, it repeats. And it does. Okay, so you can see here that the syntax between the while statement and the do while statement is very similar. But the use of it gets to be a little bit different depending on how you want to use it and depending on what you're trying to solve. Okay? Now, as always, you can also include if statements in here. And let's say, please give us a number greater than 10. Num is as next in, and we'll say if num is less than 0, system out print line, you gave us a negative number, clearly not greater than 10. And then else if num is greater than 0, system out print line, you gave us a positive number but less than 10, less than or equal to 10. So let me expand this a little bit so you can see a little bit better. And then else system out print line, you gave us 0. Okay. So now if we were to compile this, we need to stop the execution first, and then we can compile and run, and we get, please give us a number greater than 10, and let's say we do 15. We get this message, you gave us a positive number but less than or equal to 10, which is clearly not true. And the reason why we get that is because we have 15. 15 is less than 0. That's not true. It's not a negative number. And then else if num is greater than 0, you gave us a positive number but less than or equal to 10. Well, clearly that's not true. If we want to, there's a couple of things we can do at this point. We can simply get rid of but less than or equals to 10, and you can say you gave us a positive number. Or we can actually keep the previous message and simply include an additional Boolean expression. We can combine Boolean expression by saying if num is greater than 0 and num is less than or equals to 10, then we give this error message, you gave us a positive number but less than or equals to 10. Okay, let's compile this. Let's run this. 15. Now we have the other problem, because now 15 is not less than 10. 15 is not greater than 0 and less than or equals to 10. Then the only other thing it does is it goes else you gave us 0, which is clearly not true. So here we actually need to do an else if num equals to 0. Then we can also say else system out print line thanks. Now we can test all of the conditions and say please give us a number greater than 10. We get 15, we get thanks, yay, it works. Or we can execute this and we give a negative number and it says please, you gave us a negative number, clearly not greater than 10, please give us a number greater than 10. And we can give it a number 7, and now we get you gave us a positive number but less than or equals to 10. We can give it 0, you gave us 0, please give us a number greater than 10. Then finally 15, and we say thanks. So here, even though you can and sometimes are expected to execute a loop with an if statement, or in this case if, else if, and else statement inside of it, the logic might not necessarily work the way you expect it to be. So definitely when it comes to the Boolean expressions, you need to take the time to think through the problem and understand what kind of expression needs to be executed and why. And you definitely need to test it out and step through it kind of like I did and say, hey, what's happening every step of the way here? If the num is 15, 15 is less than 0, false, not executed. And here 15 is greater than 10, false, actually true, and 15 less than or equals to 10, false, true, and false becomes false. And here 15 is equals to 0, false, doesn't get executed. Everything else is false, so this is executed. Something like that. Okay, great. So that's really it for today. The idea is I want you to think about loops, and there's actually yet another loop that is a for loop, and there's also a for each loop, which I'll cover in future episodes. But for now, we're just covering the while loop and the do while loop and the basics of how loops work. And the question, as always, is what were some things that were obvious to you? Was there anything new that you learned from this episode? And was there anything in this episode that seemed obvious to me but still wasn't obvious to you at all? Please tell me in the comments if there's anything like that. And as always, if you like this episode, please subscribe for more content, as I will be providing more content such as this. Thank you, and see you next time.